Alright, let's cut to the chase. Quantum computers are here, and they're about to flip everything we know upside down. Forget what you think you know about speed and power in tech. This is a whole new ball game. Imagine solving problems in seconds. That would take today's supercomputers thousands of years. It's not sci-fi, it's real, and it's happening now. Get ready, because quantum computers can change the world in ways we can barely imagine. Ready to dive into the future? Let's get started. Computers have come a long way, starting from ancient analog contraptions like the Antikythera mechanism, which was basically a fancy clockwork used to tackle celestial events. Fast forward a few millennia, we got digital computers in the 20th century, like Turing's machine, which cracked enemy codes in World War II. Then came the transistor revolution, leading to the digital behemoths we have today, crunching numbers at insane speeds. But hold on, because quantum computers are about to leave these supercomputers in the dust. So what exactly is a quantum computer? Unlike classical computers that use bits as their smallest unit of information, bits that can be either 0 or 1, quantum computers use qubits. These qubits can be both 0 and 1 at the same time, thanks to a principle called superposition. Imagine having a coin that is spinning so fast it shows heads and tails simultaneously. That's superposition in action. To understand this better, consider Schrödinger's famous thought experiment involving a cat. Place a cat in a sealed box with a device that has a 50-50 chance of releasing a poison. Until you open the box, you don't know if the cat is dead or alive. In quantum mechanics, the cat is both dead and alive simultaneously until observed. This superposition is what makes quantum computing so powerful. It allows quantum computers to perform many calculations at once. But that's not all. Quantum computers also harness another quantum property called entanglement. Einstein famously called it spooky action at a distance. When qubits became entangled, the state of one qubit instantly influences the state of another, no matter how far apart they are. This interconnectedness allows quantum computers to process information at speeds and efficiencies unimaginable to us. Alright, let's talk about the true potential of quantum computers. These aren't just faster computers, they're game changers. First up, speed. Quantum computers blow classical computers out of the water. Take Google's Sycamore. For instance, in 2019, it solved a problem in 200 seconds that would take the world's best supercomputer, Summit, around 10,000 years. Yeah, you heard that right, 10,000 years. That's the difference. We're talking about solving in seconds what would take ages otherwise. Quantum computers can handle mind-bending calculations. Think simulating black holes or a Big Bang. Classical computers can't touch this stuff. They might even crack the code of dark matter and dark energy, the mysteries of our universe. For space travel, quantum computers could optimize flight paths, making missions more efficient. Hell, they might even solve equations for wormholes. Faster than light travel? Not so sci-fi anymore. Quantum computing will push our understanding and exploration of space to new heights. Now, let's get into industries. Chemistry is a big winner here. Quantum computers can simulate molecular structures that are too complex for classical computers. For example, understanding the exact behavior of molecules during chemical reactions could lead to breakthroughs in drug discovery and material science. Imagine being able to design new drugs that target diseases with pinpoint accuracy. This brings us to the impact on medicine. Quantum computers can model complex biological processes at the molecular level, potentially leading to the discovery of new treatments for diseases like Alzheimer's, Parkinson's, and cancer. The human body is incredibly complex, and many diseases involve intricate interactions between numerous molecules. Classical computers struggle to model these interactions accurately, but quantum computers can handle the complexity, providing insights that could revolutionize healthcare. For instance, by simulating how proteins fold and interact, quantum computers could help us understand diseases caused by protein misfolding, like Alzheimer's, and plus drugs to prevent or treat these conditions. The energy sector could also see massive benefits. Quantum computers could optimize fusion reactions, bringing us closer to fusion power, a clean, limitless energy source. They can also make existing renewable energy technologies, like solar panels and wind turbines, way more efficient. We're talking about making green energy not just viable, but the norm. Let's talk security. Quantum computers are both a blessing and a curse here. On one hand, they can create encryption so tough it's virtually unbreakable, making our data more secure than ever. But on the flip side, they can also crack any digital encryption we use today like it's nothing. Imagine every piece of secure data, banking, military, personal, becoming an open book. Governments and organizations are racing to get quantum-proof encryption in place before the tech goes mainstream. If they don't, the first with a functional quantum computer holds the keys to everyone's secrets, and that's a terrifying thought. Quantum computing is the new arms race, and it's heating up fast. Google, with its Sycamore processor, achieved quantum supremacy in 2019. IBM isn't far behind, pushing its IBM Q System 1 for practical applications. And Microsoft is betting on topological qubits to solve the problem of qubit stability. On the global front, China's pouring billions into quantum research, already launching the Mycia satellite to pioneer quantum communication. The US, not to be outdone, has its National Quantum Initiative, funneling over $1 billion into keeping America at the cutting edge. This race is about more than just tech pride. It's about who controls the future. Quantum computers will revolutionize fields from cybersecurity to pharmaceuticals, aerospace to finance. Imagine breaking any digital encryption effortlessly. That's the power at stake. The first to crack practical quantum computing will dominate economically and strategically for decades. But it's a messy, high-stakes game. Nations and corporations alike know that whoever wins this race won't just change the tech landscape, they'll reshape the world order. Quantum computing isn't a done deal yet. It's a wild ride full of hurdles. The biggest challenge? Keeping those qubits stable. Quantum bits, or qubits, are super sensitive. They need to stay in a state called coherence to work their magic. But the slightest interference, a bit of heat, a stray electromagnetic wave, throws them off, causing errors. That's why these machines often operate near absolute zero, colder than outer space, which isn't exactly practical for widespread use. Then there's the issue of scaling up. We need thousands, maybe millions of qubits working together to tackle real-world problems. And we're not there yet. It's going to be a bumpy road, no doubt, but the destination? It's a future where quantum computers transforms our lives in ways we can barely imagine right now. The tech isn't perfect, and we have a lot of work to do, but the possibilities are too incredible to ignore. Alright, let's wrap this up. Quantum computing is not just some sci-fi fantasy, it's the next big leap in technology. Sure, there are massive challenges to overcome, like keeping qubits stable and scaling up the systems. But the potential payoff is insane. We're talking about solving problems that today's supercomputers can't even touch, revolutionizing industries from medicine to energy, and even cracking the deepest mysteries of the universe. But it's not all sunshines and rainbows. This tech can also turn global security on its head, making our current encryption method look like child's play. The race is on, and the stakes are sky high. Whoever cracks quantum computing first will hold a serious advantage. If you found this video interesting, hit that subscribe button, like the video, and let us know your thoughts on quantum computing in the comments below.